So, hello everybody, to a lecture on the Discus suite. Today we are talking about error detection and error handling in macros. So when you write your own macros, what can you do when errors appear? Like those errors, in particular, were in errors which don't mention their source or their location. There are also errors which have the location written in the errors message, like error occurred in surface menu here, but these errors are quite rare. So we want to do it from a general perspective, how to find the errors and how to deal with them. Let's talk about the errors in black first. So there are different types of errors. You can look that up in the manual. But errors written in black are generally coming from your computers. You don't have sufficient computational resources. In particular here it's a memory error. You don't have sufficient memory for your calculation or even for starting Discus. In general you need to estimate around 1 GB of RAM on one core for calculating models. It depends of course how big your model is, how many atoms and what you want to do with Discus, but take that as a rough estimate. And there are these reddish errors which appear quite often when you're writing your own macros. And these macros normally appear when you have made some typos into your macro, or there are some logical problems in there. Then the program normally spits out such red errors. And we want to deal with one of them today, actually the same one here. And we take a macro from the workshop for that. I put an error into a workshop macro, which is called zinc selenide powder suite. So what it generally does, it's creating nanoparticle, a zinc selenide nanoparticle, sometimes an ellipsoid or a sphere, and creates stacking faults into this structure, so pretty much local defects. And it's normally used for later on calculating the X-ray powder pattern or the PDF and refine it to data from measurements. What we are going to do today with this macro is we are going to calculate a sphere and put some ligands on top of the sphere, just for having used a property for atoms, which I'll mention later. I have added a second phase to the macro, which is a caffeine 6-hydroxy-2-naphtholic acid co-crystal. So that means it's a 2-compound crystal, organic crystal, consisting out of caffeine and 6-hydroxy-naphtholic acid. And this co-crystal wants to be modified. We try to change molecules in there. We can change rotations and play again with local defects in there. And in the end, I want to create a caffeine poor structure. And and we want to see how we can deal with exactly doing what we want to do and get control over the process, that no errors will occur. We can identify them more easily. So with that, we'll just jump right into the macro. We're working today with Discus version 5.25 because it already has the new look. Then we are jumping into the folder of the error, which is this one. So this is the workshop version of the macro with the error in it, and we just start the refinement. The version we are looking now at is this. This is the main part of the macro. Again, it's creating some spheres here. It's doing that by using the make layers macro. It shapes an ellipsoid, powder, and output macro. And it creates this non-numerical parameters and expressions. That menu returned with error occurred in surface menu. So here's already a hint where the error occurred in the surface menu. However, we want to do it now without having the information, because most of the time this information won't be there. and it has a reason that I have chosen this error. For comparison, we look now at my macro, which I have written, which is this, which is pretty much the same macro. You can compare it easily if I'm shifting it over there. Here it is. What I've done here, so this is the original one, this is the modified version. I've put in a set weight on, that's normally used in Discus anyway. So, and after that I try to do some segmentations in the macro. So I have here the echo command. The echo command is writing out this line to the prompt, so pretty much to this window, and there we can see where the macro is actually working at the moment, and we can see where it actually stops, or which step it reaches and which not. Second thing I did in between these lines, I put in this plot block, which is just plotting my structure pretty much, so that we can also follow easily by seeing the structure what happens. So everything is pretty much identical. I just put in a few times the echo command, a few times the plot command, and here in the very end I put in just a decorate block, just for the sake of having a different atom property, the ligand property, into this macro. And here later on the second phase is edited, but we'll go to that later. So what I'm going to do now, I'm trying to use my macro now, which is identical pretty much with the modified workshop version, which has the issue, the error in it, and I'll run it and pretty much the same error should come up. However, now with some plots inside. We can just go through the macro for the moment. So pretty much reads a structure, which is the zinc selenide structure. It's an hexagonal structure, and pretty much has 2 atoms in there. And later on, so that was the first plot, and you can also see that step 1 was done, and here was the plotting macro. That we reached step 2 here, step 2 is here, and we reached this plotting block now, so which is after the make layers. So we have now created a layer out of zinc selenide, and this goes in general on. So after each bigger block I normally plot the structure and put an echo in there. So we'll go now further up to the point where the error occurs. What you see now is that we are beginning from the beginning of the loop again. So we are creating a stacked version, but we are not reaching the sphere. So what should happen normally is we're creating a layer. After that, in the shape ellipsoid macro, we have a stack, and out of the stack we just cut a certain shape, okay, some spherical or ellipsoidal shape, and then we have our nanoparticle. However, this is not happening. Instead, this error is coming up. So what have we learned from that now? We have seen we are waiting for step 3. Step 3 is here, but we haven't seen step 4. It's not coming up. So the error needs to be between step 3 and step 4, which is in the ellipsoidal macro. Luckily, I have already opened the ellipsoidal macro here, so it's somewhere in down here. Can just open it again, and yeah, that's the macro. Pretty much what you see here. There's a macro which creates a stack. The stack looks pretty fine because we have the plot here. So until that point, everything is going right. But then we have the error occurring in the surface menu, which is already teasered here. And then a lot of commands are commented out, so they are not of any use. That means in these few lines, there has to be an error. When we look at it, we see the set distance external all. It's pretty much defining atom properties around 3.1 angstrom out of an external surface. That it's okay in general. Boundary ellipsoid, diameter, and the center of the ellipsoid. We are talking about a sphere today, so all these parameters should be identical in general, because we set it identical in the beginning. And then we put in the center of the sphere, in the center of this stacked crystal. So in general, this looks pretty fine. From the number of commands, it's totally okay. So some of the parameters need to be corrupt. What can you do in this case? So you need to ask whether the parameters are correct. These are commands where you can, with them you can check parameters. Again, the echo command is giving you out the line afterwards, just printing %d. D is for the number, C is for character, so for string. Another possibility is the evaluate command, which is pretty much calculating whatever is written in behind the evaluate. And I did that a few times, just with the first parameter here, and then with 3 parameters, and then with the parameters over there for the center. When we now run the macro with these lines in there, and we just will go up to the arrow again, so just before the surface command will be read, these commands should be printed to this window. So what we can see here in a moment, so we are going through all the steps again, and we are seeing here the printout. Here at first, the first 35, the echo is pretty much this line. It's rounding, because I didn't specify the %d, the value of the diameter. So the diameter is officially at the moment 35.15. And yeah, so this is the exact value. With the evaluate, you'll get an exact value with 8 digits. And then the next 3 lines here is this evaluate, showing you the 3 parameters here. So, and again, the CC diameter is equal to the AB diameter. So in the end, we create here with the boundary command a sphere. However, the evaluation of this line is not printed out, meaning that here there's an error. However, we know that the diameter is totally fine. It's 3.5 nanometers. That's simple calculation, and so the P lattice parameter B needs to be wrong. So that stands for a parameter lattice parameter B. So, well, every crystal has a lattice parameter B. However, why is, in our case, this value wrong, or what is the value? So we can go to Discus and try exactly to evaluate again manually this value. So it's not existing. Why? When we go to the setup macro here, you see that just lattice parameter A and C is defined. In between there's no B, because we are talking about a hexagonal structure here where lattice parameter A is equal to lattice parameter B. So we don't necessarily need the B value, the B parameter here, meaning that we avoided to use it throughout the whole macro. So what we need to do here, we need to take an A or a C here, that the calculation will work. It makes more sense to take actually the C to put it in the center of the crystal. So having changed just the parameter here, we should be fine. What we can try now is to run the macro again. So we are going to this first step, layer step, stacking step. And so now we reach step 4. Step 4 is after the ellipsoidal mark, and now we have created here a sphere. Okay, and that's how we generally locate errors. We put in the echoes. You can optionally add these plots in there, but there it's a nice way to find errors, and then the macro finishes to end, so it creates the final particle sphere with some ligand decoration, and then it goes into refinement of the powder pattern down here. Okay, that was the first part, how to find an error. Now we want to see what we can do by having more control over the crystal structures. What are methods to look at or prevent errors by knowing what you actually are working with, and probably don't use these pictures anymore because they don't give you the full information. We'll see that in a moment. The macro is going on now, so it reads now a second cell. It's the co-crystal cell, and it's going to plot it. Again, it's a mixture of naphthoic acid and caffeine here in bluish. It's kind of a wavy structure, stacked also layers. So what I'm going to show you first is to show symmetry, symmetric, and show a molecule command, or respectively the show atom command. Here is the show symmetry command. The symmetry of this co-crystal is P210C, so it's a monoclinic structure with all the symmetry operations written down in here. Secondly, Discus gives out the metric, which is pretty much the lattice constants or parameters to be more exact, with A, B, C, alpha, beta, gamma, the volume of the unit cell, and the metric tensor. Lastly, we have the show molecule last. So it just points you to this window, the last molecule, and I have defined actually three molecules, so three acid molecules pretty much into one molecule. So these are the atom coordinates, number, atom coordinates, p-value of this atom, okay, and with oxygens and carbons. So, and the idea is now to replace these acid molecules by caffeine. That's what I've done here. Replace 2,1 molecule 1.0 means that I replace molecule type 2 with molecule type 1, which is caffeine. 2 is respectively the naphthoic acid, by 100%, so completely converted the molecule. That means that I've replaced all the naphthoic acid, and my crystal is now completely composed out of caffeine. Now it's becoming interesting, because what I wanted to do now is to use again the surface command. I'm setting the external to 7.9 angstrom, and I'm putting a cylinder into this crystal structure. That looks like this, hopefully. I'm putting the cylinder as outside, so I'm removing all the atoms inside the cylinder, so I'm creating a pore. In this case, to make it easier to see, it's, you know, completely shot through the crystal in a tunnel instead of a pore. However, what I created with this external command now is the set distance command, a shell around the cylinder, 7.9 angstroms long, which pretty much marks the atoms with the external flag. And there are different flags, so different marking methods of atoms, which you can't really see here in this rough picture of these molecules. Now we can go into detail here, and we want to see which flag these atoms / molecules do have. So what I've done now, I've added the show atoms all command, which is giving out something like this. And here you can see all the atoms of the crystal, which is plotted here. What's pretty much standing behind us here is the atom. It's 1nm, so it's standing for it's a normal atom with a molecule character. And here's, well, probably I can't really do that. These are the coordinates of the atom, p-value, number. And what I want to highlight here is that no flags are set for these molecule atoms. So most of them, pretty much all of them, have no flag. However, some of them have these flags E for external that were set around the cylinder with 7.9 angstrom in radius. So what I can do now, I can specify the atoms I want to work with later on. What I did now here is a chem-elem exit. So in the chemistry menu, the element command, which is one of the most used commands, yeah, it's pretty much giving you the number of total atoms and the number of unit cells and so on. But in particular, it gives you how many atoms are in the crystal in total. So you have 333 voids, 5,500 carbon atoms, and so on. You know that in the cylinder, for example, we just kicked out 333 atoms, and which are missing here pretty much, and are now replaced by a void and can be removed by a purge command. That's what I wanted to show here. And here, here are some distances and property related settings. So here again, 7.9 angstroms around the external surface and 2.5, which is an internal value for the boundary inside the cylinder. What I've done in the next step, I have looped over all external atoms. I took a loop from atom 1 to atom 10,080, and I'm looking for the marking or the flag E, and then if this loop doesn't find an E, then it removes the atom, or it removes the loop, because the loop is running over all atoms. So what it does is all atoms without the external marking are kicked away from the crystal structure. And we can see that here in the chem elem again, just before the step 9 here, that it has removed 8,622 atoms in total. And that means that we have removed all the atoms around the cylinder of around 8 angstrom in distance. So we can see that hopefully here, where we have created now a nanotube out of an organic crystal. So I'm just want to show you with that you have a lot of control by using atom properties like NM, domain, outside, external, internal surface, and the ligand molecule, which you've seen in the decoration in the beginning. It would have a ligand as flag. So that's pretty much everything I wanted to show you with this macro, that you can also with these commands and the printouts here in the window see what you're actually doing and where your error could arise from. In the very end, I just want to mention again several commands in Discus. So the chem element exit, for example, is really important. What I haven't shown you is the set error command. So what you can do is set error live. So it will run the macro without exiting Discus, and this would happen with set error exit. So you can jump over errors, whether it makes sense or not. When your program is terminating unexpectedly, just insert that or start the Discus in a separate Discus shell within Discus, so with the system Discus read, for example. So again, set the wait on off if you don't want to have to wait when in a wait return command. That's quite useful. What else? And the show commands, of course, are really important at some stage. Also, if you print out the log files, you can nowadays see all the errors which appeared in the log files. And that makes it really easy when you are calculating on bigger computers and servers to find your error. Okay, with that, I wish you a very nice day.